you are welcome to Math Secret Revealed by Dr. OJ. The title here is 5 important rules. In this video, we start with examining the rules that guide integration of some functions. So we try to see if we can complete all the rules in this video. But if we cannot, then we continue with the next. With the subsequent videos. So in the first case, what is the rule? The rule 1 says that the integral of a sum of a finite number of functions is the sum of their separate integrals. The sums here include addition and subtraction, as the case might be. The difference. Now, let's look at example to illustrate this rule 1. I want to apply rule 1 in solving this problem. Example. Let's call it example 1. The integral of x squared plus sine x plus square root of x all dx. Now, if we look at this given problem, it contains 3 different functions. According to the statement, the integral of a sum of finite number of functions. We have finite number of functions here. We have 3 functions here. The first one is algebraic function x squared. Sine x is a trigonometric function, and the third one is exponential. Square root function. Sorry, that's a slip of tongue. Square root function. So we have 3 different types of functions here. So we have the integral. We have to find the integral of a finite number of functions. Is the sum of their separate. Sum means that you separate this integral x squared dx, split them. You are as if you are expanding sine x dx. Then plus another one, the last one, square root of x dx. So you can rewrite this, as x squared dx plus sine x dx plus x raised to the power half dx. Okay? Now solve the problem. Now integrate. You apply the rules. Let's integrate. The first one, x raised to the power 3, that is, obviously you should have known that 2 plus 1 all over 2 plus 1, that's the plus, plus, if you integrate sine x, you have minus cos x. Check the standard again, then plus x raised to the power half plus 1 all over half plus 1 plus c. We cannot leave it like this, we have to evaluate completely. Okay? So what next? Let's simplify. So we're going to have x raised to the power 3 all over 3 minus, when you open this, you have minus cos x, then plus x raised to the power 3 over 2 all over 3 over 2 plus c. We can leave it like this, but as a mathematics students, it will not be too proper. We can re-evaluate this and have x to the power 3 all over 3 minus cos x plus, you are dividing the entire numerator here by 3 over 2. So 2 will go up and 3 will come down. So you have 2x is power 3 over 2 all over 3 plus c. So I think it's okay like this. If you still want to simplify further, then this will be square root of x raised to the power 3. But I can leave it like this, so it's alright. It's okay. It's okay. So let's look at another example. The other one is, look at this. The integral of exponential x minus cos x dx. Yes. So, just as we have done for this, applying rule 2, you have what? The integral of exponential x dx minus the integral of cos x dx. That's all. Just separate them. Okay? And remember, in one of our standard forms, The integral of x dx is what? Integral of x. I told you. Then minus, when you integrate cos x, you are going to have sine x. So plus c. It's as simple as that. So let's leave that. Let's go to another rule. Because of our time, at least we should be able to observe 2 or 3 rules in one of the videos, so that the bulk of our work will be eased. I don't want us to have too much, explanation locked up in a particular video, so as to have videos that are not, going to take much of our time. Let's look at rule 2. Rule 2. Rule 2. A constant factor may be brought outside. A constant factor may be brought outside the integral sign. The integral sign. A constant factor may be brought outside the integral. Let's examine that. Let's look at an example. Let's say example 1. Okay, we can continue our example with, let's call it example 3. The integral of 6x squared, 6x raised to the power 4 dx. Now, this one is saying that you can bring out a constant factor outside the integral sign. A constant factor here is 6. You can bring it out. Yes, it's allowed. That is 6 integral x raised to the power 4 dx. It's allowed. So that means you have what? 6 into, now integrate this, x raised to the power 5. How? Because I think you must have you must have understood x raised to the power 4 plus 1 all over 5 plus c. You must have understood that. Okay, now what? 6 all over 5 x raised to the power 5 plus c. It's as simple as that. Let's look at another example there. Let's call this one example 4. Let's call it down. We have integral 5 all over u du. This is a brilliant one. This is a brilliant one. Now, we want to bring out the constant. The constant here is in numerator, so it could be brought out as 5 integral du all over u. Yes. Bring out 5. It will mean 1 times the u is the u all over u. Okay? And if you could recall, in one of our standard forms, we said the integral of the x all over x is log x base e plus c. Yes, it's there. Check the standard form. So that implies that we now have what? 5. This du over u is the same thing as is equivalent to dx over x. If you look at it, so now have what? Log u, exponential, log u base e, log u base e plus c. So that solves that. Let's look at another rule, please, because of let's look at another rule. I think let's look at rule 3. Let's look at rule 3. Let's look at rule 3. So we now, after this rule 3, we continue with other rules in the next video. So rule 3. Rule 3, the addition of a constant to the variable makes no difference to the form of the result. How does this apply? Let's look at the example here. Call this example okay, example, we ended with example 4. Let's call this example 5. Example 5. Suppose we are asked to integrate cos 5x dx. Now, Cos 5x dx is not the same thing as cos x dx. Don't get it wrong at all. They are not the same thing. They are not the same thing at all. So, there are two ways to this. There are two ways to this. Let me teach us one of the ways. I will teach us both ways, but let me start with the basic one. Which is going to be integration by substitution. Let u be equals to 5x. I want to show us how we are going to arrive at our answer here. Let u be equals to, the function of cos. That's a value for cos there. So if you differentiate u with respect to x, you get 5. Can you still remember that? This differentiation now. The u dx will be 5. You know that. Remember? 1 times 5, 5. 1 minus 1, 0. So anything is 0 is 1. So 5. 5. So that means the x could be, from here now, the x could be, that is, you cross multiply. You have the u be 5 dx. Abi? So the x will now be what? The u over 5. Do you agree with me? Of course now. If you cross multiply, the u equals to du times 1. This one is over 1. Du times 1 du equals to 5 dx. So we now make dx the solve formula. You now divide both by 5. So dx will be du over 5. You can check. So now going back to the problem. You now have what? That means you now have cos 5x is now what? Replaced by u. Now your dx now is what? Is now du over 5. Of course. So which means that you can from what you have just learned, from what we learned in root 2, you can extract the constant out. So that means you can have 1 over 5 integral of cos u du. Yes? Cos 5 is a denominator, so it will be down, not up. So 1 over 5, we bring it out, it's a constant. So which will now be what? 1 over 5. And when you integrate cos u du, it's like you are integrating cos s dx. So that will give you what? That will give you sine u plus c. You remember? Sine u plus c. Because when you integrate cos x, it will give you sine x. So which will now be 1 over 5 sine. And what is your u? Your u is what? 5x plus c. So that is it. We have jumped here by virtue of the fact that this question is related to what we will learn in future. But I just decided to show us how we arrive at the answer, basically. So when each time you are integrating functions like this, just divide the function by the constant there, 1 over 5. Then now integrate the function generally. If you integrate cos x, you have what? Sine x. So as our x here is being what? 5x. So just write sine 5x. Just like if I ask to integrate, for example, now say integrate sine 4x. Now this is not difficult at all. You don't need to consult all these methods. If you are writing a CBT, you don't need to waste your time. Just first of all write 1 over 4, which is the constant here. Then when you now integrate sine something, it's going to be minus cos something. So now minus cos 4x plus c, because you have to correct. That's what? Minus 1 over 4 cos 4x plus c. So let's stop this video here and continue with the next video. Don't forget, click on the notification bell so that each time I upload a video, you'll be notified. Thank you.